Today we'll be dealing with the sampling design, and tomorrow we'll be dealing with the statistical tools for data analysis. So two related topics dealing with research methodology. So I understand that you are having sessions on different aspects of research methodology by different uh, resource persons. I'm happy to be part of the exercise, and I consider it a privilege to be uh, engaging this session. And I have already engaged two sessions. Now this is the third, I think, and tomorrow also I'll be engaging a session. So what I do is presentations, as you know, PowerPoint presentations. So I will switch off my video and I will share the presentations. Okay. So sampling design. So this is what we are going to see today. It's a very important part of the research process. The research process consists of, in my last presentations, I had presented that the research process consists of different sequential activities, different sequential steps. This sampling comes somewhere in between before data collection. So one important aspect is data collection, and we collect data for primary data. We collect the data from respondents. Uh, so we select a sample and collect data from the sample respondents. So before data collection, we have to do this sampling. So how to do the sampling? There are a lot of confusions, a lot of doubts about the sampling, how the sample is to be selected. This is a very important aspect of the research process because the sample has to be selected properly. So today we are going to understand the sampling design. Yes. So we start with why do we need sampling? I hope you can see the slide moving. So the need for sampling. Why do we need sampling first of all? When a study involves a large number of people, a small group is selected for study. This is what happens when a large number of people have to be studied. Say, for example, the bank employees or bank employees of Kerala. Supposing you are making a study about the commercial bank employees of Kerala. So it's a large number of people, so many banks, so many branches, so many employees are there. So then what we do is we select a small group is selected for the study. And that's what is known as sampling. Selecting a small group for studying the larger group is called a sampling. What is the purpose or what is the advantage? It reduces the time and the cost of the study, first of all. So it reduces the time of the study, cost of the study. If you are going to study the population, it takes a lot of time. It involves high cost, uh, and it is not necessary. It is not necessary to study all the people, the entire population, we say. Also, it is not possible also. So first of all, it is not necessary. Secondly, it is not possible. So we usually resort to what is known as, especially when the population is very large, we resort to the process called sampling. A sample study is sufficient to provide reliable results. So we want to collect data and analyze the data and come with the reliable results. So we want results which are reliable about the population for which a sample study is sufficient. But there are certain conditions. That is what we are going to see. The sampling has to be done in a systematic manner to ensure the reliable results. So we want reliable results which are relating to the population. But for that, the sampling has to be done in a systematic manner. And that is what we are going to study. how to do the sampling in the proper way, in the systematic way, in the standardized way, so that you will get reliable results. This is the purpose of our today's session. Okay. Now we are trying to understand the different dimensions, aspects of sampling. The first thing that you should understand is the difference between population and sample. What is a population? What is a sample? Most of the things that I am presenting today will be known to you. Some of the things may not be known, but most of the things will be known. But there should be clarity about the terms used, the procedures used. That is the purpose. So you should be clear about. I presume that all of you are either doing research or intending to do research. So you should have a clear idea about the sampling process in research. So two important terms, population and sample. Population, all of you know, all the units of a study. When you're making a study, you are studying some phenomenon involving people, because ours is a social science. Commerce management is social science. So we are dealing with people. We are studying the different problems of people. So people are involved. So all the people involved in our study who are affected by the study, that is the population. All the units of study. It is called unit of study. The people who are involved are known as units of study. Say, for example, employees, bank employees. They are the units of study. Population means all the units of study. Sample means a small group selected from the units of the study, from the population. So from the population, we are not going to study the population, entire population. We are going to study only a small group selected from the population. That small group is called sample, but the question is how to select that sample. That is what we are trying to understand. The sample that we are going to select for our study should be a representative subset of the population. It should be representative of the population, expected to exhibit the properties of the entire population. So it should be a representative subset of the population, and it should exhibit the properties of the entire population. So your subset should exhibit the properties, all the properties of the entire population. So it should be, in other words, it should be a representative subset. It should represent the population. Very often I give the best example for sampling is, see, when you make tea, for example, you prepare a tea by mixing tea and milk and so on. And finally, you will put sugar. Okay. Then you will mix the sugar. Using a spoon, you will mix the sugar in the entire tea or coffee. Then you want to find out whether this tea or coffee has sufficient sweetness or sugar. What do you do? All of us know we take a spoonful of coffee or tea from that whole tea, and we taste it, and we say that if this tea, the table spoon that we are using, and the tea that you take from the entire tea through the tablespoon, if that is sweet enough, you conclude that the entire tea is sweet enough. So this is sampling. So this is, you should do it after mixing there. You see, why do you mix the sugar? That is the question. See, you are mixing the sugar so that it is covering the entire tea. And then you take a small teaspoon. So the sample should represent the population. And that is enough. The sample is enough provided the sample represents the population, because that is logical. If the sample is representing the population, we are selecting a small sample. If that sample is representing the population, that is enough to get the results. And we can conclude that the results are applicable to the population. So that process is what we are going to study, how to select a representative sample. That is the important point. The composition of the sample should be representative of the population. The population may consist of different groups, different characteristics, and so on. So your sample should also have those different characteristics of the population. That is what is meant by representative of the population. How we can ensure that? That is what we are going to study. Okay. Again, we are trying to understand a few words which are related to sampling. Two important words are parameters, statistics. Parameters and statistics. Population parameters. The full name is population parameter. These are the values relating to the population. Supposing you are studying the stress of bank employees. Bank employees are having a lot of stress nowadays. Your study is about the stress of bank employees, and you are measuring that on a 5-point scale. And so the entire bank employees of Kerala, what is the stress? What is the mean stress? So what is the stress of the entire population? That is the population parameter. The population parameter. So the stress of or the mean stress of the entire population of bank employees in Kerala is called the population parameter. It is the value relating to the population. It is unknown. We do not know. We are trying to find out. So we are trying to understand whether there is stress among bank employees, how much is the stress among bank employees. We are going to measure that and find out the value for the entire population. Now it is unknown. Now we are selecting a sample and measuring the stress of the sample employees, and we will get a value. That value is called sample statistics. Sample statistics. So the value for the sample is called sample statistics or simply statistics. The value for the population is called parameter. So we don't say population parameter, sample statistics. We simply say parameters. Parameters means the values relating to the population. Statistics means the values relating to the sample. So after your study, what you find out is the value relating to the sample, not the value relating to the population. That is unknown still. Still it is unknown. The population parameters are unknown. They can only be estimated. They cannot be calculated. Sample statistics can be calculated because we are collecting data from the sample. So we can calculate the sample statistics. But population parameters, we cannot calculate because we are not studying the population. They can be estimated from the population, the sample statistics. Using the samples, the values of the samples, called sample statistics, population parameters can be estimated, not calculated. Estimated. So there can be error. It's not calculation, you will get the correct result. For the sample, you will get the correct result. For population, you can estimate the values, but the estimated values may be more or less from the real value. So the population has a value. Supposing you measure all the units and find out a value, that is the population value, but we are not doing that. The value is there, nobody knows that. We are only studying the sample and calculating the sample, measuring the sample values, and from that we are estimating the population parameters. Our estimate may be, it will not be exactly equal to the population, real population parameters. It may be a little less or a little more than the population parameters. How much is that? That tomorrow we'll be studying about statistical tools used for this estimation. This process of estimating the population parameter from the sample statistics is called statistical inference. So in the research process, you should understand, in the research process, there is a very important statistical procedure known as statistical inference. How do we do the statistical inference? Tomorrow we'll be dealing with that. How do we estimate the population parameters from the sample statistics? That is called statistical inference. Today we are only trying to understand how to select the sample from which the data will be collected, and the data will be used to calculate the values of this sample. They are calculated values. From that, using statistical tools, we will be estimating the population parameters. So two the topics are connected. Today's and tomorrow's topics are connected. Okay, so now we are coming to sampling. Sampling simply means selecting for study a part of the universe. Population is otherwise known as universe. So selecting for study a part of the universe or population relevant to the study is what is known as sampling. As I said earlier, the sample should be representative of the population, and sampling design helps in selecting such a sample. Today's topic is sampling design. So sampling design, what does it mean? It means how to select the sample. How to select the sample which will be representative of the population. So that is what we are going to see. Sampling design, we have understood what is a sample, what is a population, what is statistical inference, why we are doing the sampling, and so on. But how to select the sample, that is what is known as sampling design. So let us look at the meaning of sampling design. It is part of the research methodology. So when you are doing research, you have a research methodology, and one of the components of the research methodology is the sampling design. In other words, it is a plan for design. Always means a plan. When you are preparing building a house, first you draw the plan of the house. So that plan is called the design. So it's a plan for obtaining a sample from a given population. So there is a population which you want to study. You want to study the population. There is a population. Example I gave you was bank employees of Kerala. All the bank employees in Kerala. So that is the population. And you are planning to make a study about that, their stress level. So you want to have a sample. So you should have a plan for obtaining that sample or selecting the sample. That plan is what is known as sampling design. So what are the components of that plan? What is to be included in that plan? We will see shortly. The sampling design has to be determined before data collection and even before doing the sampling. Before selecting the sample, before doing the data collection, we should prepare a sampling design. And what does the sampling design include? I'm going to show you what the sampling design includes. It includes three things. First, sampling methods. How do you select the sample? Sampling stages. There are different stages in selecting the sample. It's called sampling stages. Then sample size. What is the size of the sample? Is it 20, 30, 100, 200, 300, 250? So what is the sample size? So sampling design, you have to decide about three things. What is the sampling method that you are going to use? There are different methods. So what is the method that you are going to use? Sampling stage. There are different stages in the sampling process. Which are those stages in your sampling process, in your study? Then sample size. How much should be the sample size? Should it be 200, 250 or 300 or just 50? These are the three things. So now we are going to understand these three things which are part of the sampling design. Features of sampling. features of sampling. So let us understand some of the features of sampling. Only then we can answer those three questions. Type of the universe. Universe means population. Another word for population is universe. Type of the universe. See, the universe may be finite or it may be indefinite. Indefinite means we do not know the size of the population. Indefinite. The size of the population. The size of the population, not the sample. Size of the population is unknown. It may be 3 lakhs, it may be 4 lakhs, it may be 5 lakhs. We do not know. So that is indefinite. In some cases, the size of the population may be known very clearly. Then it is called finite. So when the size of the universe is known, it is called finite. When the size of the universe is unknown, it is called an indefinite population. Now, another word used is sampling unit. Sampling unit is the item to be selected. In the example which I gave you, the sampling unit is bank employees. So a bank employee, a commercial bank employee in Kerala. That is the sampling unit, the item to be selected. Sampling frame. So these are terms which are related to the sampling design. Sampling frame. The source list of the sampling units. Sampling unit in this example is the commercial bank employee in Kerala. Sampling frame is source list. Supposing there is a list, if there is a list of all the employees, then that list is called sampling frame, if it is available to you. In fact, in the case of bank employees, each branch has a list of employees. Each bank has with them the list of employees, their employees. But it may not be available to you. That is the question. It may not be available to the researcher. So if a list is available to the researcher, then that list is called sampling frame, from which we will select the sampling units. We will select the sampling units. So that list, if it is available, that list is called sampling frame. Now, sample size. Sample size we know. The number of units to be included in the sample. That is the number of sampling units. Number of sampling units selected from the sampling frame. Number of sampling units selected from the sampling frame is the sample size. It may be 30, it may be 50, and so on. So these are different terms used with regard to sampling. We say features of sampling. Sampling method. Sampling method. Sampling method is the procedure to be used for selecting the items. How do you select the items? What is the procedure that you are using to select the items for the sample? That is called sampling method. We'll study about it in detail later. Sampling method. Okay, so we are starting with the last one. Methods of sampling. We have understood what is a sample unit, which is to be taken from the sampling frame, and a sample size sufficient, consisting of sufficient number of sampling units must be selected. But how do you select? Methods of sampling. Okay. There are two important methods of sampling. Some of these things you may know, but should have a clear idea. That is the point. Should have a clear idea about the different methods. Random or probabilities sampling. Random or probability sampling. Selection is done on a random basis without any criteria for selection. So selection is done on a random basis without any criteria for selection. So there is no criteria for selecting. We are not fixing any criteria for selecting. The selection is done on a random basis. The opposite is non-random or judgment sampling. Here, Selection is based on some criteria. Selection is based on some criteria. We fix a criteria for selecting the sampling units. Sampling units. You know what is the sampling units? So we are fixing some criteria for selecting sampling units. The selection, therefore, will depend upon the judgment of the researcher or expert. He fixes a criteria, then based on that criteria, he will select the sampling units. So it is based on his judgment. The best example of random or probability sampling. So you know lottery, the government has lottery, Kerala lottery. Supposing, uh, say, 50,000 people have taken lottery tickets. 50,000 people have taken lottery tickets. So, and each lottery has a number. Each lottery has a number. Okay. So we have to select the first prize. How do you select? That is the question. Is there any criteria for selecting? Is there any criteria for selecting? Is it to be selected on the basis of, say, first prize, second prize, three prizes? Let us supposing we want to select three prizes. First prize, second prize, third prize. So, is it on the basis of any criteria? Like, for example, first prize should come from northern region. Second prize should be from the middle central region of Kerala. And the third prize should be from the southern region of Kerala. Or first prize should come from male purchasers, male customers. Second prize should come from female purchasers. See, these are criteria. Is there any such criteria? There is no criteria. In the case of lottery ticket, absolutely no criteria for selection. No criteria for selection. All are equal. Male and female customers are equal. Northern region customers, southern region customers, they are all equal. Young people. Or is there a criteria that there should be first prize should come from the senior citizens, second prize should come from younger people, third prize should come from the middle-aged people. These are examples of criteria. In the case of lottery, there is no criteria. Anybody can win the first prize, second prize, third prize. So that is what is meant by random basis. Selection is done on a random basis without any criteria. So here they have a sampling frame. Here there is a sampling frame, That is, there's a list consisting of all the lottery which has been printed. There's a number. Each lottery ticket has a number. So we can prepare a list. The government has a list consisting of all the numbers. Lottery ticket numbers. 50,000 lottery tickets were printed and sold. So each lottery ticket has a number. There is a list. That is the sampling frame. Sampling frame. So from the sampling frame, we are selecting three. First prize, second prize, third prize. Without any criteria. So we, on a random basis, we prepare a lottery method, lottery method, mixing it up, or using random number table. Either using random number table or mix up. Put all the numbers in different papers, mix it in a bag, and take one. Take the first one, first prize. Take one more, second prize. Take the third one, third prize. There's no criteria. That is the best example of understanding what is a random selection. But for doing random selection, we require a sampling frame. That is the point. If you do not have a list, then you cannot do random sampling. So random sampling, so that means it is called probability sampling. Each person has equal probability. The 50,000 people, so the probability of success of each person is 1 by 50,000. Each person has equal probability, 1 by 50,000. So that is why it is called probability sampling, random sampling. Now, the other one is non-random sampling, which is called judgment sampling. There we apply some criteria for selecting the sampling units. Okay, now we will look into random sampling. Again, is divided into four different methods of random sampling. Simple random sampling, stratified random sampling, cluster sampling, systematic sampling. These are the four different methods of random sampling. We will try to understand each one. Then we will have different methods of non-random sampling. We will try to understand each of them. And when you are doing your research, you have to apply one of them. Either one of these random sampling methods or one of the non-random sampling methods. So we will see one by one. Simple random sampling, stratified random sampling, cluster sampling, systematic sampling. Simple random sampling. Method of sampling that ensures that each item in the population has an equal chance of being included in the sample. The lottery which I mentioned. Method of selection that ensures that each person who purchased the lottery ticket has an equal chance of being included. That is the simple random sampling. We require a sampling frame. We require a list. And we can use random number tables are there. Now computer will generate and give you a random number table. So using that random number tables from the list, the random number table will give you a series of numbers. So from the list, these numbers can be selected. So that is called random number tables. Lottery, or you can use lottery method. If it is a small population, you can use lottery method. Say 1,000 numbers are there, you can put it in a box and take one. That is lottery method. This is simple random sampling. Stratified random sampling means it is appropriate when the population is already divided into different groups. The population may be consisting of different groups. Like, for example, supposing the study is about, let us say, bank employees, we have private banks and public sector banks. So private sector banks and public sector banks. Already two groups are already there in the population. The population, bank employees is the population universe, and this consists of two groups of people, public sector bank employees and private sector bank employees. So two groups are already there. So these groups are called strata. The groups are called two strata. Okay. And random samples are selected from each strata. From the list of public sector bank employees, we select a random sample. From the list of private sector bank employees, if the list is available to you, it is available to you, you can make a random sample from the two strata. So that is called stratified random sampling. The population is already stratified, divided into groups already, and from each group, proportionately on the basis of the population proportion, the same proportion, we select a sample also. The size of the samples from each strata depends upon the proportion of each strata to the population. If the public sector bank employees are 70% of the total bank employees and private sector bank employees are 30% of the total bank employees, your sample also should consist of 70% public sector bank employees and 30% private sector bank employees. Your sample should be in the same proportion as the population. This is stratified random sampling. Example, or another example, employees may belong to two strata such as officers and clerical staff. Two strata. Okay. Cluster sampling. The third type is called cluster sampling. We are speaking of random sampling, cluster sampling. It is used when the population consists of many groups. The population consists of many groups, each group being representative of the whole population. Read it carefully. It is used when the population consists of many groups and each group is representing the entire population, represents the whole population. The groups are similar to each other, unlike in the case of strata. In the case of strata, the groups are not similar. They are different. Their salaries may be different. Their status may be different. Here the groups are similar. Population is consisting of different groups, but the groups are similar to each other, unlike in the case of strata. And these groups are known as clusters. The groups are known as clusters. And a random sample of such clusters. Supposing there are 100 clusters, we select a random sample of 20 clusters. So clusters are already there. Clusters are groups within the population which are similar, and we are making a random sample of such clusters. We are selecting because all the clusters are similar. Each cluster represents the population. So we select 5 or 10 or 15 clusters. Example, see, many wards of a panchayat. Supposing you take a panchayat, this panchayat consists of many wards. There may be 7 or 8 or 10 or 20 wards. See, this each ward is similar. Each ward is similar. So the panchayat is divided into different wards based on location, but the wards are similar. So each ward is, we call it a cluster. So if you want to study that panchayat, you need not take all the clusters or all the wards. You need not take all the wards. You take 2 wards or 3 wards. That is called cluster sampling because the wards are similar to each other. Therefore, the wards are known as clusters, and this sampling method is known as cluster sampling. Systematic sampling, again, is commonly used. Systematic sampling. Items are selected from the population at a uniform interval from a random starting point. So we have a list here. For random sampling, we need a list. We need a sampling frame. So we have a list of employees. So from a random starting point, anywhere, so 30th employee, a 27th employee, or 16th employee in the list. Starting point is random, not the first employee. We are not starting from the first employee. We are starting from a random number list. So 16th employee. From there, we are selecting at a uniform interval. The next, we are starting the selection from a random point in the list. Then we select at a uniform interval from the list. Like this. Read the example. From the list of employees, every 10th employee may be selected starting from the 6th employee. Starting point is random. 6th employee. 6th employee in the list is the starting point. That is random. It can be any number. It can be 16. It can be 27th employee. It can be 110th employee. Any employee. That is starting point. But after that, we have a uniform interval. Every 10th employee or every 5th employee or every 100th employee after the starting point. So there is a systematic, we are following a systematic method because we are having a uniform interval. We are following a systematic method. Therefore, this is called systematic sampling. This is a commonly used method provided you have a list. Now we come to non-random sampling. So most of the research studies, we have to use non-random sampling because you may not get a sampling frame or a list of the respondents or sampling units. So let us see what are the non-random sampling methods. There are different methods: purposive sampling, convenience sampling, snowball sampling, quota sampling. So these are the 4 methods of non-random sampling. You should understand clearly these methods because these are the methods that you will be able to follow. One of these methods you have to follow. So let's start with purposive sampling, non-random sampling, purposive sampling. What is purposive sampling? It is there in the name itself, purposive sampling. So remember, non-random sampling, we always use a criteria. We use a criteria for selecting. Purposive sampling, selection of the sample is based on some specific purpose. Therefore, it is known as judgment sampling. So the purpose is, whether the purpose is fulfilled, is judged by the researcher. So we can call it purposive sampling, judgment sampling. For example, we may say we are studying bank employees. Okay, fine. But we may fix a criterion. We will take bank employees with minimum 5 years experience. Because a bank employee who has just joined, he will not know anything about the bank. So we need bank employees with the minimum period of experience. So that period is fixed by the researcher. The researcher says 5 years, 3 years. So you are fixing an experience. So you have a purpose here. So a criterion is there. What is the criterion? The criterion is you want to have bank employees with at least a minimum of 3 years experience. So you have to apply your judgment to find out. You have to find out whether the employee has 3 years experience, and only from those employees we can make a selection. So this is called purposive sampling. So some criteria will be applied, some purpose will be used for selecting the respondents or sampling units. Next one, convenience sampling. The selection is made on the basis of availability or convenience of the sample units. It is also known as opportunity. There should be an opportunity to meet them and collect the data. So we should have an opportunity to meet and collect the data. They should be available. They should be convenient. Remember, it is not the convenience of the researcher. We are not speaking about the convenience of the researcher. We are speaking about the convenience of the sample units. So here there's a misunderstanding. Very often, when you do research, you misunderstand it as convenience sampling is misunderstood as the sampling based on the convenience of the researcher, not at all. It is the convenience of the sampling units. Say, for example, you are studying the bank senior managers of banks, supposing you are studying the senior managers of different banks. So senior managers are very busy. So they will not have much time to interact with you. They are already busy. So their availability and convenience. So you can only collect data from the senior bank managers who are available, who express their convenience to give data to you. So that is what is called convenience sampling. It's also called opportunity sampling. Next is called snowball sampling. Snowball sampling. If you go to North India or if you go to European countries, very often you will see that in the morning there will be no snow. Supposing you go to a mountain region in North India. So there will be no snow in the morning. By afternoon, small pieces of snow will be falling there, here and there in the mountain. By evening, more snow will be falling. By night, the entire mountain will be covered with snow. See, that is from that we are taking this name, snowball sampling. Initial respondents are very few. Initial respondents like snow in the morning, snowballs in the morning are very small. Initial respondents are small. They recommend other respondents, and so more respondents will be joining you. So you will get more and more respondents by the end of the study, even though initial respondents are very small. So initial respondents recommend other respondents related to the research problem. The best example, you would have heard of cryptocurrency, cryptocurrency trading. It is not allowed in India. It's happening all over the world. In India, Reserve Bank has not yet approved it, but it is happening in India. But nobody knows who are doing this cryptocurrency because it is prohibited, it is hidden, it is secret. People lose money. So they will not reveal that they are doing cryptocurrency trading. So cryptocurrency, supposing you are conducting a study about cryptocurrency, you will not get the sampling unit. There is no list. You won't know who are the people who are doing cryptocurrency trading. But you may be able to find out a few people, one or two people who are doing cryptocurrency trading. Initial respondents. Say you found 3 people who are doing cryptocurrency. So you collect data from them. They know other cryptocurrency traders. They will know because they have connections. So they will be able to tell you, give you the address of other cryptocurrency traders. So you approach them, and another 10 people will be recommended by these initial respondents. Then these next 10 people will give more names. So another 40 people will be joining. These 40 people will give another further names. So finally you will have a large number. Like the snow ball in the mountain, increasing from small snowballs in the morning to full mountain covered with the snowballs in the evening. This is called snowball sampling. In certain studies, only this method can be applied for sampling. So we are studying the methods of sampling, non-random sampling methods. And quota sampling. The last one is quota sampling. It is similar to the cluster sampling in the case of random sampling. Quota sampling. It is similar to, it is similar to the stratified random sampling. We have studied stratified random sampling earlier. The population is already divided into two strata groups, which are not similar. Here also population is subdivided into subgroups. The population is already subdivided into, you are not dividing, the population is already subdivided into subgroups, and you are taking a quota of the sample units is determined for each subgroup. So from each subgroup, because subgroups are different, each group is different from the other groups. So from each group, you are selecting a quota of sample units. A quota means a number, maybe 20, 30. A quota of sample units is determined for each subgroup, and sample units are selected from each subgroup on non-random basis to fill the quota. So you will select the sample from each subgroup. You already fix the quota of units to be selected, and that quota will be selected on a non-random basis using either purposive sampling or convenience sampling. So this is quota sampling. It's not very commonly used. The commonly used are the first two: purposive sampling, convenience sampling. Okay. So we have understood sampling methods. Random sampling methods, non-random sampling methods. Now we are coming to sampling stages. Sampling stages. There are different stages. There may be different stages in sampling. So it may be a single stage sampling, or it may be a multi-stage sampling. So sometimes there may be only one stage, single stage, or sometimes there may be multi-stages in the sampling process. In the selection of sample units, there may be different stages. I'll give you one example. Multi-stage sampling. Example. So there will be different stages. 2 stages, 3 stages, 4 stages. Supposing you are studying about the bank employees of Kerala. All the bank employees. Public sector, private sector, and so on. All the bank employees in Kerala is the population. So your sample should be representative of the population. Your sample, in the beginning, we said that in the beginning. The sample should be representative of the population. This population consists of bank employees in different parts of Kerala. See, the population consists of bank employees in different parts of Kerala. Bank employees consist of banks, public sector banks and private sector banks. Public sector banks and private sector banks in different regions. So different regions are there, different banks are there, and each bank has different branches are there. So the population is diverse, it's not uniform. It is not uniform. So your sample also should be diverse. It should cover the entire population to be representative of the entire population. In such situations, we apply multi-stage sampling. Here, let us look at this example. First stage, we select regions and districts. We divide Kerala into 3 regions. Usually, Kerala we divide into 3 regions: northern region, central region, southern region. Each region consists of 3 or 4 districts. The northern region consists of 3 or 4 districts. Southern region consists of 3 or 4 districts. So we may select one district from each region. So in the first stage, we are dividing the whole state into different regions. From each region, we are selecting one district. This is to represent the entire state, because northern region is different from southern region, and southern region is different from the central region. Second stage, we have different banks are there. So we have public sector banks and private sector banks. So we have to select. So there are many public sector banks and many private sector banks. The population consists of all the public sector banks and all the private sector banks. We are not going to study all the public sector banks and all the private sector banks. We are going to study only sample. So we have to select from the public sector banks, we have to select one or two. From the private sector banks, again, we have to select one or two or three as a sample. That is the second stage. So we have selected districts in 3 regions. We have selected a few, 2 or 3 public sector banks and 2 or 3 private sector banks. Second stage. Third stage, we have to select bank branches in the selected district. See, we already selected banks. Let us say Canara Bank from the public sector and Federal Bank from the private sector. And we have selected 3 districts. So we have to select now the bank branches, the branches of the selected banks in the selected districts. Okay, so we have to select bank branches of the selected banks in the selected districts. Third stage. So we have not yet reached the bank employees. Who are the sampling units? The sampling units are the bank employees. We have not reached, we have reached 3 stages. We have completed 3 stages, but we have not yet reached the bank employees. Fourth stage, we are now selected the bank branches. Now we go to the bank branch and select the employees or customers. If your study is about customers, you can select the customers. If your study is about employees, you can select from the bank branches in of the selected banks in the selected districts. You are visiting that and you are now selecting the employees. So only in the fourth stage you are able to reach the employees or customers. This is called multi-stage sampling. So this sampling procedure requires 4 stages. 4 stages to be representative of the population. Your sample has to be representative of the population. It has to cover the entire Kerala. It has to cover both public sector banks and private sector banks. So the 4 stages are required. And finally, we reach the selection of employees. And for selecting the employees, we will have to apply either non-random sampling methods or random sampling methods. If the bank manager, you are visiting a bank branch, and if the manager of that branch gives you the list of employees, you can apply random sampling. If the branch manager does not provide you the list, you have no list, you cannot apply random sampling. Then you have to apply purposive sampling or convenience sampling. Understood now? So now we come to the third aspect: sampling methods, sampling stages, sample size. What should be the sample size? What should be the sample size? This again is a very important question and a very confusing question. Researchers do not know what should be the sample size. So let us understand how to find out the sample size. Samples are described as small sample, large sample, based on the number of units in the sample. Based on the sampling units, number of sampling units in the sample, in statistics, we describe the sample as a small sample or large sample. And the criteria in statistics, we are speaking about statistics. Small sample, the sample size is less than 30. N is less than 30. large sample, the sample size is greater than or equal to 30. So if the sample size is greater than 30 or equal to 30, we say it is a large sample. If it is less than 30, we say it is a small sample in statistics. But it is not applicable to research study, our social science research. This characterization of sample size is not appropriate. We have a different definition of sample size here. What we want here in research study is not a small sample or large sample here. See, in research, we are not concerned about a small sample or large sample. We are concerned about the optimum size, optimum sample size, which will be representative of the population and which will give you a reliable data. So we are not looking for small sample or large sample. We are looking for optimal sample size. So sample size for research study, sample should be of optimum size. Optimum size. Optimum means the ideal size. But what is that size? That is the question. Two criteria for determining sample size. One, representativeness. It should be large enough to be representative of the population. It should be large enough to be representative of the population. If the population is very diverse, if the population is homogeneous, a small size is enough. If the population is diverse, then you require a large population, large sample to be representative of the population. That is one criteria, representativeness. Second criteria, reliability. We want data which can be used for estimating the population values. I told you in the beginning. Parameters, we want to estimate the parameters. So we will get sample statistics from the sample, and this should be reliable, which means it should be sufficient. See, it should be sufficient to provide data from which inferences can be in the sample. We are not at all interested in the sample. We are interested in the population. We are interested in the population. We want to know what is the population's value, which can be estimated from the sample value. So the sample value should be reliable. So the size of the sample should be sufficient to provide reliable data from which inferences can be made. That is called statistical inference. So optimum sample size. How do you determine, how do you calculate the optimum sample size? The optimum sample size depends upon three factors. First factor, the level of precision required. See, we are going to estimate, so there will be mistakes. From the sample statistics, we are going to estimate the parameter. Naturally, estimates will not be equal to the real values. Estimates will be, there may be different real values unknown. So how much is the precision that you require, or how much mistake can you afford? How much mistakes are you prepared to afford? 1%, 2%, 3%, 4%, 5%, up to 5%. Usually up to 5%. Up to 5%. Plus or minus 3, plus or minus 4, plus or minus 5. Next one. Level of confidence regarding the inference. So we are going to make an inference about the population. How confident are you about your estimate? What is the percentage of confidence? If you are taking 100 samples, we cannot expect that the value will be applicable to all the 100. The value that we are estimating will be equal to all the 100 cases. At least 95% So we want at least 95% or 90%, 95%, 99%. The researcher can decide. So the precision level, the researcher can decide. Confidence level, researcher can decide. Conventionally, we take 95%. So that means out of 100 cases, in 95 cases, the result estimate will be true. True with regard to with the 3% error. See, the error we have mentioned earlier. First, we have mentioned the error. So we are confident that in 95 cases, out of 100, 95 cases, the result will be, the estimate will be true with the possibility of plus or minus 3% error. Okay. Next one. The third factor is the degree of variability or the extent of variation in the attributes to be measured. So we are going to measure some value, income, stress. So we are going to measure some value. So what is the degree of variation? In some cases, the variation may be more between people. What is the stress? What is the variation of stress among employees? Is the stress, is there a high variation among the employees, bank employees, of their stress? Or is there only a small variation in the stress? So we are going to measure their stress, but is there a high variation or low variation of stress among the employees? That is another important point. So if there is only small variation, a small sample size is enough. A small sample size is enough. Okay. So these three factors are taken into consideration for determining the optimum sample size. There are formulas incorporating these criteria of precision, confidence, and variability for calculating sample size, and we are going to see those formulas. Sample size formula for estimating population proportion, population values, and so on. So sample size formula. First, we have to determine what is the population. Is it definite or indefinite? We have already said population may be definite, known, or it may be indefinite, unknown. That is the first thing we should know. Then we have a formula, Cochrane, the formula given. There are many formulas. One popularly used formula is the one given by Cochrane, this formula for indefinite population. We start with the indefinite population. So he has given a formula for indefinite population. N is equal to, the sample size is equal to Z square into P into Q divided by E square. So we will see what is Z, what is P, and so on. Z means the standard score representing the confidence level. We said three factors are there. Confidence level. So is it 95% confidence? Is it 90% confidence? Is it 99% confidence? So there is a standard score for that. I'll show you in the next slide what is the standard score for representing the confidence level. That is Z. So is a square. P, the variability, variation, the third factor. The variation in the variable that we are, the attribute that we are going to measure. There what we use is we take 0.5 because that indicates the maximum variability. So we are assuming that there is maximum variability. So variability of the attribute is taken as 0.5. Q is 1 minus P. So that again will be 0.5. 1 minus 0.5 is again 0.5. E is the precision, the first factor. First factor. Precision required. Desired level of precision, 3%, 4%, 5%. Okay. So let's take the confidence, Z score. For confidence interval, Z score is a measure of how many standard deviation. Z score is a standard deviation below or above the population mean. We are going to estimate the population mean. So Z score represents how many standard deviations below or above the population mean. The raw score can give us this confidence level. 90%. Supposing you want 90% confidence level, then the Z score is 1.65, 95% 1.96, 99% 2.58. So in the formula, we'll be using the place of Z we'll be using. Normally we take 95%, so we'll be using 1.96. Okay. Let's take an example. Sample size for precision level of plus or minus 4% and confidence level of 95%. 95%. So Z square, 95%. Z value is 1.96. Z square into P. P is 0.5 into Q, 0.5 divided by E square. E is 4%. 4% is converted into decimal. It will be 0.04%. 600 is the sample size. If you are prepared to go for more errors, precision level, you are saying that you want only 5%, you are allowing 5% errors, then the sample size will be less. Sample size. If you want more precision, 3%, 2%, then the sample size will be more. If you want more precision, such as 2% or 3%, that is, you are allowing only 2% error or 3% error, then the sample size will be more than 600. But if you are allowing 5% error, then your sample size will be lesser. Okay, so this is how we calculate the sample size. Now, this was for indefinite population. Now we are looking for finite population, adjustment for finite population. So what we do is we can adjust the previous formula, n adjusted for finite population. The sample size is adjusted for finite population. That is n, the n which you get for indefinite population, divided by 1 plus n minus 1 divided by n, capital N, where n is the sample size, n, capital N is the population size. Because the population is finite, we know the size of the population. That size is called n, capital N. Capital N. Example. Supposing the population size is 5,000 units only. A small population consisting of 5,000 units. So capital N is 5,000. 5,000. So we have already worked out earlier sample size for an indefinite population we worked out as 600. So now we are trying to find out the population, the sample size for a finite population, the population which comprises of only 5,000 units. So n, look at the formula, n divided by 600 divided by 1 plus n minus 1, 600 minus 1, divided by capital N, which is 5,000 units. So that is 600 divided by 1.1198 is 536. So for finite population, a lesser sample size is required compared to indefinite population. So this is how we are finding out the population size for sample size for finite population. There is a direct formula. So it is too complicated. So you can take the other formula for indefinite population and adjust it. You will get the sample size for same sample size, 536. If you apply the direct formula also, you get the same sample size, 536. Okay. Now we are coming to, so we have understood the three important things: sampling methods, sampling stages, sample size for an indefinite population and for a finite population. So that depends upon three factors. The three factors are decided by the researcher, but conventional practice is to go for 5% precision level, 95% confidence level, and maximum variability, which is measured by 0.5. Now, when you are doing your research, there can be errors called sampling errors. So let us understand what is meant by sampling error. How does it occur? So that is what we are trying to understand. Sampling errors. Sampling error means the difference between sampling error. Sampling error means when you are taking the sample, taking the sample parameters and estimating the population sample statistics, estimating the population parameters. Difference between the sample values, which we are calculating from the sample which we have taken. That is called statistics. And population parameters. Population parameters. So we are using the sample values for estimating the population parameters, but there may be a difference. That difference is called sampling errors. Sampling errors. So we want to reduce the sampling errors. Therefore, in the formula, see here, look at this formula. We want to reduce the sampling errors. So, therefore, this precision level or error level, this is the error level, this we will reduce. We want to, if you want to reduce the sampling error, you should use in your formula, you should use 2%, 1% or 2% or 3%, then your sampling error will be reduced, but then the sample size will increase. So to reduce the sampling error, you can use in the formula, instead of 4%, you can use 1%, 2% or 3%. Then your sampling error, difference between the sample values and the population parameters will come down. Sampling error will come down. But then when you use this in the formula, when you use 1% or 2% or 3%, the sample size will be larger. So larger the sample size, the more reliable the data. Larger the sample size, more reliable the data. When we do research, in our research, we usually use 5% so that our sample size will be around 385, 400. Because we are using, we are allowing 5% error. Okay, so sampling error will be 5%. But see, there are many research organizations in the country. They have a lot of money. They are funded by government. When they are doing research about Indian economy, they conduct research, and they are conducting research covering the whole country. They will use, because they have money, so they can say researchers do not have much money. They cannot afford. They cannot collect data from a large sample. So our sample size should be less. The research organizations, they will be using the error percentage, they will reduce to 1% or 2%, but the sample size will be more. But they have money, so they can collect data. They have people, money, so they can collect data from large samples. We normally, conventionally, fix the precision level at 5%, and our sample size will be around 385. Okay, so we are speaking about sampling errors. Sampling errors. Sampling error means difference between the sample statistics which we have calculated and the population parameters which we have estimated. So the difference, there will be some difference. That difference is called sampling error. It may result from a small sample size. It may result from a small sample size. So sampling errors may decrease as the sample size increases. So if you want to reduce sampling errors, you have to increase the sample size, which PhD scholars may not be able to do, but research organizations can definitely do that. This occurs when sample is not representative of the population. So when the sample size is small, that sample will not be representative of the population, and therefore the sampling error will be more. Okay. Now there are non-sampling errors. Sampling error comes because of the sample size. Because the sample is not representative of the population, sample size is less and so on. Non-sampling errors are something else. What are they? These are the errors that arise in the process of data collection. See, we are collecting data using sometimes the researcher himself collects the data, or we use our friends or other people, enumerators, to collect the data. And the data, very often there can be correct data may not come, they may not tell you the truth. So when you are studying questionnaire, I think we already had a session on questionnaire. So there we try to make the questionnaire perfect so that you get the correct data. But still, there can be errors in the data collection. So the errors that arise in the process of data collection is called, it is not because of sampling. See, these errors are not because of sampling. The other one was because of, this one was because of the sampling, sample size. So that is why we call it sampling error. This is not because of the sample size. It is not related to sample. It is related to data collection. So we call it non-sampling errors. Errors that arise in the process of data collection. It causes the data to differ from true values. The data that we are collecting may not be the truth, the true values. The respondents may not give you the true values, or you are making mistakes in collecting data and doing the calculations. So when you do the calculations, you make mistakes, or they may not give you the true values. They will tell you lies. So the data is differing from the true values, and the types of non-sampling errors. Non-response error. Sometimes they may not respond. The sampling units, the employees may not respond. Measurement error. See, they are giving the wrong, when they are using a scale, they are giving the wrong answer, measurement error. So they are giving the wrong answer. Interviewer error. Supposing you are interviewing them and you are noting down wrongly, you made a mistake in noting down what they are saying, or you have not understood what they said. So there can be errors on the part of the interviewer. Processing error. When you are doing the calculations, when you are entering the data into the computer for processing, or when you are giving the data processing commands in the software, you may make mistakes. So all these mistakes are due to data collection, not sampling. And these can be avoided to a great extent. Or in fact, they should be avoided. So they can be avoided to a great extent, and they should be avoided as far as possible. So two types of errors. Sampling errors cannot be avoided, but non-sampling errors can be avoided by careful collection of data. Okay, so that is as regards what we say sampling design. Sampling design. So what we saw today was sampling design. That means how to collect, how to select a sample, reliable sample, representative sample, to make the sampling errors as low as possible. Reference books, you can refer to these books. This is a good book. Kothari's book is there, Umashekhar Kothari, John Best. It's a good book. And I have also written a book, I think I showed you last time. This is Methodology for Social Science. Yes, so I think we will come back and you can ask questions. My respondents, one query here is, my respondents are women IT employees who had taken a career break more than 6 months and then re-enter the workforce. Whether my sampling method is purposive or convenient sampling. I think now you would have understood. So women employees, you need not, convenient sampling is used when the sample units are difficult to approach. I gave you the example of uh, I gave you the example of senior bank managers. So convenience sampling is used when we cannot approach the sample units easily. Here, you have to use not convenience sampling. Your sampling is purposive sampling because you have a purpose. You are taking people. That's the criteria for selecting. So it is purposive sampling. Okay. You want the reference book? I'll show you the reference book. Yes. Somebody is asking for reference books. Once more, I'll show you. Okay, Swati has understood. Yes.
Good evening, sir. Sir, I had a question, if I can ask with your permission.
Yeah, definitely.
So my research area is effect of fintech in CRM in selected public sector and private sector banks. Now I am planning to select two PSUs and two private sector banks. So my universe would be the customer base of these two banks or like the entire banks in a particular area. Like I would be selecting Navi Mumbai. So, and would be taking, like, as you said, in multi-stage sampling. So, in that also, there will be two banks from public sector and two banks from private sector. I'm planning to take, sir. So, while deciding my sample, my universe should be the entire base of Navi Mumbai or the base of these two banks in Navi Mumbai.
No, entire Navi Mumbai.
Entire.
Just like
So
Kerala,
then,
we said. I gave you the example of Kerala in the same way.
yes.
Navi
So it will
Mumbai.
be an indefinite population, sir. Or
Yeah,
definite.
indefinite
Okay, thanks.
population.
Thank you.
And you have to use multi-stage sampling.
Yes, I would be using that list.
Multi-stage sampling, correct? Yeah.
Yes, thank you.
Okay. Okay, go ahead. Others. This is the one participant asked for reference books. So these are the reference books. Okay. You can ask questions, no problem. Others can ask questions. Today's topic is simple, comparatively simple, in the sense that there are no complications involved. It's easy to follow. So no doubts may not come. Much doubts may not come. So chat box, I think there is no. There are no questions.
Hello, sir. I'm
Yes,
Priyanka.
yes. Go ahead.
I'm Priyanka. I have a question. Sir,
Louder.
if the population is indefinite, how to do the sample frame?
How to do
Sample frame,
sample
frame.
sampling frame. So
Yeah, sample frame.
in that case, you have no perfect sample frame.
Okay.
See, perfect sample frame means the complete list. So
Yes.
when the population is indefinite, you will not have a perfect sampling frame, but you may get some list from somewhere. So part of the list may be available. So from that, you can use the criteria for selecting. So that is you will not have a perfect sampling frame when the population is indefinite. Only when the population is finite, you will have a perfect sampling frame, a full complete list. In the other case, the list will be incomplete, but there will be a list. You will get a list which is incomplete, but we can use that. We can use
Okay, sir.
that. Mhm.
Okay, sir. Thank you.
Okay. There is just one more doubt here. Can we use parametric tools while using non-random sampling methods? I'll answer that tomorrow. We are dealing with the statistical tools. So I'll answer that tomorrow. Okay. That is all. So, good night to all of you. So join tomorrow at 7 o'clock so that we can. Tomorrow's session we require more time, so try to join on time itself. Okay. Good night to all of you. I am leaving with your permission. Okay.
Thank you, Professor, for an
Okay.
enlightening session on sampling design. Your guidance has been truly enriching and inspiring. We are grateful for your valuable contribution. And with that, we come to the end of the day one. We appreciate all of you for your active participation and engagement. As Sir said, we will continue with the second day tomorrow. That will be focusing on the statistical tools for data analysis. We invite you to join us again at the same time, 7 p.m., using the same link. We look forward to seeing you all tomorrow. Thank you.